Welcome to the next installment of the JKMRC Friday Seminar Series that take place here in Indopili and online. My name is Karina, and myself and Katerina have the honor of organizing the seminars and introducing the speakers this year. Before we start, on behalf of the University of Queensland and the Sustainable Minerals Institute, we would like to respectfully acknowledge all traditional owners and the custodianship of the land on which we all meet today. We pay our respects to the ancestors and their descendants who continue cultural and spiritual connections to country. We recognize the valuable contributions to Australia and global society. Our speaker today is Dr. Stephen Rayward. He has a varied career, starting as a computer-based Exce design and developing some algorithms for operational research. He also worked on physical oceanography, analyzing both oceanography and coastal. He then moved from the sea to the land and completed a PhD in the mineral processing at JKMRC. In turn, this led to a research position at JK, with Stephen's passion being the application of liberation data to mineral processing. He was involved in a variety of research projects and commercialization activities, but from 2009, he worked independently on a variety of contract positions, software development, and providing courses. Today's presentation is a new general flowsheet-based simulation system in Excel. Please help me to welcome Dr. Stephen Rayward.
Well, thank you, Karina and Katrina, and thank you for all of you who have come to listen. I want to tell you at the outset, this is going to be a fun lecture, I hope, because some of you are historically friends, and I can't help myself but joke around a little bit. Here I'm simply going to talk about a software system I created called ExcelFlow. Whilst it's still in development, it's good enough that people can use it, and if you have interest, integrate your models into it. Now, it's a general system. It's not specifically designed just for mineral processing. So in giving this presentation, and this is based on a presentation I recently gave at Minerals Engineering at the Integration and Optimization Conference. I'll just turn this around so I can look at it. In giving this presentation at Minerals Engineering, I had to think, well, I only had 15 minutes. Should I give it from a research viewpoint, from a software design viewpoint, or from an application viewpoint? And for that reason, the application is a separate video. But I decided to speak as much as I could from a research viewpoint, and certainly not from a software development viewpoint, which some of you might well be interested in, and you can talk to me. Now, I also should add that I'm happy to take questions as we go from everybody except Craig Brown. Just kidding, just kidding. I would really look forward to questions from Craig. Oh. Okay, let's. I'm not getting anything. Maybe that one else. Keep going. All right, I'm going to have to move. This isn't working. Sorry for that. Can you line it up properly, thanks? So the application example will be from Aminpro, their flotation model. So about a month ago, I wrote to people and asked who would like to integrate their models into the simulator, and Roger Amaluxon put his hand up. So I took his models and applied it to my framework. So the question, which many of you are probably already asking, and it's a fair and reasonable question, why on earth do we need a new flowchart simulator? Now, the answer is, of course, yes and no. It depends on your requirements. So I'll answer why yes during this presentation, but I do understand that some people will already use simulators, that you'll be happy with them and you'll see no reason to change. And I certainly respect that. Now, I'm quite active in LinkedIn. I'm not sure if all of you are in LinkedIn, and I've distributed my card, and if you wish, please connect on LinkedIn. But many years ago, about 8, there was a discussion in LinkedIn, and someone asked the question, what's a good simulator for mineral processing? And then we had people respond, often with one-line answers. Use this software, use that software, careful not to name names. And a whole host of people would write in and just say, use this simulator, I love it, or it's great, or whatever they would say. I wrote in and I said, but what do you want the simulator for? What are your requirements? And this is where it got interesting, because the original poster said, I don't know. I don't know what I want it for. I just want to know what's the best. Now, the scary thing is that in mineral processing, that sort of conversation actually happens. But it'd be like someone saying, I want a car, and someone says, well, get a D-Max or get a BMW or get a Ferrari. It makes no sense whatsoever without addressing the needs of the individual. I'm sorry if I didn't mention your favorite car. So I wrote back and I said, well, here's some criteria for a simulator. Now, this is even an abbreviation of what I wrote, but I wrote up these criteria, what you need to look for in a simulator. This particular, what I wrote in led another person, Bazdu Rupal, to invite me to South Africa to talk about simulation. And so even though it's only a one-page PowerPoint, you can talk about this for a day easily, and comparing different simulators and getting people to assess, people who use simulators to say whether it's user-friendly and so forth. And not all simulators scored highly, and when we did a comparison, and indeed no simulator actually scored highly, although some were doing a lot better than others. So basic criteria: how expensive is it? Is it for designing a plant or operating a plant? Is it user-friendly? And then I've flagged these 3, which are important to me. Is it connected to a flowchart system? Is it extensible? And I'll explain that in the talk. Is the data structure appropriate? Which for me, for coming from a background of liberation, data structure was extremely important. Can it be easily integrated with a relational database? Are the available models accurate? Now, I don't think those comments are particularly radical, but I've discovered a few times when I say things which are fairly straightforward, that somehow it's actually unique, that people go, oh, we haven't heard that before. Now, for me, I wrote in on LinkedIn and was invited to speak at a course in South Africa, which went for 3 days. Obviously, it wasn't just that slide. And I started to get more involved in teaching. And here I can acknowledge groups such as JK Tech, LIM, another system which is no longer available, Colscan, it's not a Colscan, Colsen. And they were really helpful because they were happy for people to know about their software, and they were happy for me to give honest opinions. So, First off, they were really good in supporting, and as far as I know, they still are. But more and more, people didn't want to know about these third-party simulators. They wanted to get down and do simulation themselves. So I started to provide exercises in using Excel. And slowly but surely, there was enough justification for me to keep progressing and create a simulator in Excel, particularly one which was cost-effective. So vision of ExcelFlow is to extend the capability of Excel from a cell-based calculation tool to a highly sophisticated visual programming tool. For researchers, and that's you guys, the opportunity to release your research methods to the wider community. So specifically targeting, I'm getting most traction with the mining industry, even though it's general, and also suitable for graduates, postgraduates, and other researchers. So that was certainly satisfying an individual need of myself. So there were two key properties, extensibility and flexible data structure, which were very important to me, and I am expecting it to be important to others. So extensibility and flexible data structure. So if you take some systems, they say, this is the data structure you must use, size distributions, floatability, components, however they define it, and that's the world you live in. But I wanted something which could be flexible, so that it didn't have to be stuck just in mineral processing. I could now apply it to civil engineering problems or chemical engineering problems. But in terms of data structure and relevant to this course, this seminar, it could use a data structure which is one I would be happy with. And you'll see my logo, the multi-mineral particle. When I was at JK many, many years ago, I was certainly an advocate of this multi-mineral particle approach. And I probably should, now that you're a JK audience, you know, the history here is the fact that I worked a lot with the MLA. I did a lot of work on liberation models, and I was involved in the development of JK SimFlow, the early stages. We did in fact start with the vision of using particle-based approach, but that vision changed, which sort of left me hanging a bit because I didn't quite see how integration of comminution and flotation could work. And even now when I read papers where people claim to integrate flotation and comminution, I remain quite skeptical. So this led to Excel framework being a general framework, ExcelFlow being a general framework. Now, I know some of you are involved in simulation, and certainly you use not just JK models, but the system that I find my system most easily compared to would be Simulink, and I believe one or two of you might have had experience in that. Is there a raise of hands that people use Simulink? Nobody? Okay. Well, Simulink is a variation of MATLAB. It's produced by MathWorks. I understand certainly some of you use MATLAB. I used MATLAB when I was here, and it's a very powerful system. I couldn't really master Simulink, and I also found it hard to use. But if you were to go out in industry and you say, hey, I'm a Simulink expert, you're going to get the reaction, I have no idea what you're talking about. What you do know is that, anyway, it's coming up, but mineral processors use Excel. Now, the evolution of this development and the historical relationships with other systems. I was involved with the JK Tech software, more the mass balancing contribution, which went into SimNet, SimFloat, and there was another product which I'm not sure if it exists, frankly, JK Multibal. And then there were other products I wasn't involved in, SimSand, SimCol, and I don't know if they exist. I have no idea. I haven't followed the history of the JK Tech software at all. Now, Dave Wiseman was the software developer for JK Tech many, many years ago. And he wanted the JK Tech software to be extensible. Now I'll explain what extensible means. Extensible means not rigid in the models that you have to use. But if you have a preference for another model, it can be integrated into the system. Now that was important to me because I had developed models here as a researcher, and it was a difficult process, and I succeeded with the mass balancing. But there were other things that I had developed which I wanted to see integrated and commercialized, and they weren't gaining traction. Whereas if it was an extensible system, I saw that it could be integrated. Now, Dave Wiseman left and started his own software system called LIM. It is Excel-based, it's got connected to a flowchart, and it's extensible. Now, I developed a mass balance model, and then when I was independent, it seemed natural to integrate my mass balance model with LIM. And it turned out that when we tried to do that, because Dave Wiseman and I were working together, it actually ended up confusing the already existing LIM users. And this was a difficult thing to come to terms with. But when we talk about mass balancing, if I were to use the expression mass balancing with you, you would have an idea of what I meant. You would understand. But when I gave my course in South Africa and I used the expression mass balancing, I realized that their concept of mass balancing wasn't the same as mine. I'm not going to give a mass balancing course here, but I realized that people's perception of what mass balancing means is different. And the LIM users had a different perception of what mass balancing was. And it just seemed that it wasn't going to work connecting my mass balance with LIM. And so I, out of necessity or belief that there wasn't, I wanted to actually release my mass balance system more generally than the JK Tech software, that I started the development of my independent system. But then I made a change and said, for whatever this independent system is, I want it to be flexible and available for other applications besides mineral processing, because I wasn't getting really enough justification in mineral processing to justify a total commitment. Now, my view of optimization and simulation, there could be a slide here. I haven't shown it because it's too much of a digression, but I explain in my website my ideas on simulation, and I have 9 steps required to simulate and optimize a operational mineral processing plant. And what I discovered was the way I thought it should be done was different to the way other people thought it should be done. Although no one has ever disagreed with my approach, they just do it differently. And I actually discussed that here 10 years ago. If I start talking about it now, I won't get back onto ExcelFlow. So I will talk about it. But I believe it's a logical and structured approach to mineral processing simulation using modern mathematical techniques, such as information theory, machine learning, thereby extending the utility of mass balancing. So a critical path is a different viewpoint of mass balancing to extend its capability beyond the conventional approach. So why did I use Excel? Well, Excel was not my first choice. It evolved that I became aware that if you would have a show of hands from mineral processors in industry and you said who uses MATLAB, you might actually get 1 out of 1,000. People love Python, but not mineral processors. So you wouldn't get much show of hands in that. But if you said who uses Excel, even people who hate Excel, and there's many of them, use Excel. So Excel wasn't my first choice, But because I was giving courses, it so happened that I realized the market would be in Excel users. So most mineral processors use Excel. Excel does have a flowchart system. I don't know if people here are familiar with Visio, but it's primitive compared to Visio. But then if you want to do things in Visio, you have to pay more money. So my original vision was, in fact, to use the flowchart system from Visio. That's a separate topic, which we can go into afterwards. But I decided, no, I like the approach of using Excel in the first instance. Excel has beneath it an easily available language, Visual Basic for applications. And I was already providing courses in simulation, and they were far more easily achieved using Excel. So people do learn things if you make things in Excel. So flowcharting, flexible data structures, extensibility. And the core concept of ExcelFlow is the use of templates in Excel. And by the way, just to make sure I'm on the right path here, if I'd ask here who uses Excel, raise your hands. One exception, one at the back. Oh yeah, he reluctantly put his hand up. Yeah, I mean, a lot of people sort of they don't want to admit it, but they use Excel, and that's actually one of the reasons. I actually now provide a lot of different types of courses, but one I get most traction is, in fact, teaching engineers how to use Excel, because it's a weird relationship engineers have with Excel. You go to any conference and you're bound to get an argument. Someone's bound to say how bad Excel is, and then you say, "Oh yes, but do you use it?" Well, yeah, of course I do. You know, and so, but they don't learn. They don't want to learn because they hate it, and the result is it becomes self-fulfilling. So you don't like Excel, therefore you don't put the energy into learning it. Therefore, what you create isn't very good, justifying the fact that Excel's not a very good system. But it is actually very powerful if you get to know how to use it. And I don't even think Microsoft knows how powerful Excel is. So Excel has flowcharting capability, which I'll get to. It's not really well known that you can add your own icons. And certainly Dave Wiseman, it's difficult to understand how he understood Excel so well when he branched out to create LIM. I still think what he did was almost a miracle. His ability within a few years to start up a system, LIM, and have it market accepted so quickly. But he could see the advantages of LIM, and I would say far beyond what other people could see. So here's an example flowchart that you can create in Excel. Now, did you realize you can create a flowchart like this in Excel? Yeah, yes or no, it's okay to, yeah, some of you yes, some of you no. So you can create it. Now, because I had a good relationship with Dave Wiseman, and it's not exactly, we still have a good relationship, but he gave me a lot of information, and he gave me a lot of his icons. Well, he said they're not private, they're not proprietary, you can use them. So I collated all of them. And so you can actually do a flow chart of a mineral processing system. Again, I prefer using Visio, but you can do it in Excel. So that's the flow chart which I'll be using in the application. Now, in terms of creating a simulator, you simply have to really understand very basic concepts, such as a shape is where a unit model goes. And here I'm confining the discussion to mineral processing. The system is developed to be broader than that, but I'd only want to focus on how to do it in mineral processing. So the shape is a unit model, and the connectors, which are these, are strings. And of course, every one of you will have seen that sort of thing. And so what do we actually have here? Well, we have connectors, which all have the same data structure. And we have here units, which are all the same model. So when we have the first and the second unit is what you would call in software language a different instance of the model. It's not actually a different model. I once met an accountant who works in Excel, and he boasted that he had created over 1,000 models. And I said to him, I don't believe it would be possible to have 1,000 different models in accounting. What he had actually created was 1,000 different instances of a model. He actually never developed a model. And so this whole idea of what is a model is important, and it's something where I've written articles in LinkedIn explaining what I think a model is. Because many people who say they've created a model actually haven't. So shapes correspond to unit models, connectors correspond to instances of data. So for mineral processing, connectors are strings. And as I said, Excel allows any data structure. So if we can come up with a general way, a general framework, then our simulator can allow any data structure. So for mineral processing, the data structure for each stream is the same, of course. So here we have an example of a data structure. You define it how you want. This is pretty top level stuff. For ease of calculation, the compositions here are proportional rather than percentage. Don't worry about it too much, but it adds up to 1. So that's a simple data structure that I use for my first application, integrating a flotation model. Now, once we define our data structure, we simply create a worksheet called connector TMPL. That tells the flowsheet system that all connectors have this data structure. So that's the simple way to say that what the data structure is. But of course, Excel allows any type of model. Hence, a simulator can have any type of model. So in a general framework, everything becomes much easier. Unit models are also defined using templates. So here is a unit model, and we're not going to interrogate the actual equations or anything like that. But the model here would be called Flotation TMPL. So it knows that every time it sees a flotation cell, this is the model to be used. And it's simply you have your feed and it calculates your con and your tail. So from the user viewpoint, that's all they need to do. All they need to do is create a unit model and give it a name which corresponds to the shape that's being used, and now they can integrate their model into the simulation system. So as you can see, it's very easy. So if someone says, I want to integrate my model into your system, all I'm going to ask for is something like this, where you tell me, what is your feed and what are your calculations to get your products? I might break here and just explain that this is really all very obvious, yet I'm not aware of any other software which does this, not something which creates such a general framework as this at all in Excel. So the way it runs is it simply copies those connectors, it copies those unit models and creates new worksheets and strings. But then it works out the connections. So where you have the flowchart, let's go back, it interrogates that flowchart and works out the connections between connectors and shapes, and then it applies those connections to the new worksheets and the new units, and the simulation is completed. Now there's lots of other options, but that's basically the guts of it, and I'll show an example in the MP4 player video. So that's basically it. So ExcelFlow has its purposes. It's a useful teaching tool. It's a useful prototyping tool. So there is a communication issue between mineral processors and software developers. At times it's belligerent. They're just two different worlds. But if a mineral processor can actually construct using these unit models, then a software developer can say, all right, well, we want to get it out of Excel. Let's create a more commercial version, which I have no problem with, but he's got something to work on. It's also a useful commercialization tool. So I will be commercializing my software using this system, particularly the mass balance system. But for you, the researcher, at least had I been here 10 years ago, I would love this sort of thing. So I've created something I personally would love, but it would allow a method for researchers to release their methods to the wider community. So I have developed a mass balance system. I actually developed it 10 years ago, but then I decided I wanted this general Excel framework. It's integrated in that. I do give courses in it, but it'll be released more formally in 2023. Mainly because I'm busy writing online courses and it's incredibly slow to write them. And eventually that will lead to releasing an online course on how to use the mass balance system. So one of the issues I've had to face is the fact that when I do get courses in Excel to mineral processors, it is mind-boggling that even though they use Excel, that their Excel skills are not very good often. And so that's why I had to end up teaching more and more how to use Excel. So there's a contact that you've got my card. This acknowledgement, I want to certainly acknowledge David Wiseman, who I worked with, and many of the concepts I certainly got from working with him. Roger Amaluxon provided the flotation model, and over the years, the course participants have always provided feedback, both positive and negative. Now, I need to close this and then show I would like help, just to make sure I know what I'm doing. You can tell me what to do. I know I can press that, and should I close this?
No, of course, just click.
Just click it?
Yeah.
Okay. My name's, I'm just have to skip because you already heard all this. But I'm now going to move off. No, I'll just stop this for a moment. Go straight to Excel. So, yeah, I created an online video which gives an example. You can ask questions and I can stop it as we go, but I didn't want to muck around with the computer here. It's too stressful. So, but this is pretty close to the way I would do it on a computer, but I have cut out sections to make sure it's a little bit faster as well. I'll press play. I'll go to the flow sheet. Okay. Now, Excel is a brilliant system, completely underutilized. Now, this particular talk is not a course on how to use Excel. It's simply an overview of how it can be applied. The course takes about 1 day, but then it assumes you have certain Excel skills, and so there's enhanced courses which teach Excel skills, which are useful for creating applications in ExcelFlow. You'll see, for example, I use my own ribbon commands. Now, and I have quite a few commands which aren't necessarily all to do with simulation. So we basically start with a flow chart of what we describe. In this case, it's a series of 7 cells, flotation cells that make up a rougher plane. And each cell is named, and that's critical to being able to use ExcelFlow, is to be able to use names. So the names are there at the top left. You'll notice that Excel, you can download icons. So you're not limited to simple shapes like circles and squares and so forth. And I put everything into this frame. The skill set to create this flowchart is available in online courses. Now, I take this flowchart. Sorry, I won't apply yet. I'll also explain what I'm doing. So here we see connectors and we see shapes. The flow shape, the shapes are abbreviated by, so have it start, flotation underscore. That tells Excel Analyzer that this is a flotation ExcelFlow device. We could have worked it out by looking at the shape, but it's better at this stage to keep things consistent and use the shape name. And we have these connectors. Some of the connectors are final columns, and this is the final tag. So I create a worksheet called connector. Now, this stuff on up here, I'm not going to discuss in too much depth. That's really to be covered in the course. But what we'll look at here is string properties. And basically, we define a string. Mineral processing, they use the word string rather than connector. And this is the way the data is laid out. So in ExcelFlow, you can lay the data out any way you want. It doesn't have to be mineral processing. It could be electrical information, such as voltage. Let's not digress too much from mineral processing. And so that's the connector information. And here we have a flotation model. There is the extra information on the right, which is indeed important for the simulator, but we won't go to it in depth here. Now these, I heavily use cell styles, color styles, and these are the parameters of the unit model. I define what the inputs are, which is a connector, and I define the outputs over here. I heavily use name ranges. So over here, I'm just giving information about the way that the shape relates to the inputs, connectors, or I'm going to use the word strings from now on, input strings and output strings via the connection point. So a connection point is back on the flow sheet. It's where this connects to the shape. So I've shown flow shape, flotation template, and connector template for this application. That's largely all you need. I do have another worksheet called loaders. Which is information which is used on all produced worksheets. I won't explain this too much in depth. So now let us look at the model itself. we see a feed, and from that, we make a series of calculations, and we end up with our column and our table. Now notice in these calculations, we refer to the feed, which I've said over here is an input. And in the connector, transfer, I refer to flotation template. It's getting information from flotation template from the final results. Now it takes a while to get used to this. Once you get used to it, it's easy. So now in the show application, we simply run this, and we want to load, we want to set, flotation analysis, we want to set the flow sheet. So we say set. So it says select the flow sheet, this is the flow sheet. We go here, and we select it. Now we want to process the flow sheet. There are various options on how we process it, but we're just going to say process flow sheet. We don't see any results, but it is being processed. So the VBA now knows what the flow sheet is and the relationships between the connectors and the shapes. I now want to relate the connectors and the shapes to data in the workbook, even though that data may not exist. So we say set. And it's just called direct. So the various options you have here, but direct means that the name of the shape or the name of the connector will be the name of the worksheet. And this, which is, do we want it to be a worksheet or name range within the worksheet? We want it to be dedicated worksheets, so we have a worksheet. We want it to go into flotation, excellent. Then, so we say apply. We do the same for stream. So when it comes, this already means that I can do things like hyperlink between the flow sheets and the data and the data to the flow sheet. But there isn't any data yet, it hasn't been created. So go back here. But if I did have data, I'll be able to hide it. So we're now ready the flow sheet. Now we do something with the flow sheet. We have two different rhythms. Fn was the analysis of the flow sheet. Fn is the flow sheet application. So because of the way the rhythms work, we now want to transfer the flow sheet data. And we determine the application, which is over here. I want to copy worksheet, which means I'm going to do copy of the templates and create worksheets for each stream and for each shape. Now, there's some commands here which are seems just a little bit slow, but unfortunately, if I don't use them, I do get activation errors. So now, when I set it, I had to load it. I want all the information. This is where it's getting the template information, and the templates are in Flotation.excelFlow. Now, when I run these applications, it uses other workbooks, which is why some others are being shown. Obviously, I need to hide these a little bit more, but for the moment, don't worry about it. I'll just open up Flotation.excelFlow. View, triggers. Okay. Now, what we're going to do is simply run it. Now, this isn't the simulation itself, that will be the second step. It's basically copying all the template files and creating new worksheets. So obviously this is fast, it's automated. But in simple terms, it still thinks that it's a template file. What we want to do is replace all this template information with the actual shapes and connectors. And go along to replace, but this is how the simulator works. It's actually looking at each of these, looking at the flow sheet, and it's recreating the information about which shape it is and what it's connected to. So these light blue areas are what will be changed. And you don't have to worry about it, it's done automatically by the system. So now goes another application set, and it's called the copy model. Obviously, there's lots of other applications here, and they're all flow sheet oriented. So when I created this software, it wasn't just to use for simulation. There are lots of other applications where you have flow sheet information. Initialize it. Nothing happens in initialization because it has all the information it needs, so just kept these as the four commands, and now I run it. And what it's done is do a replace of all those connected informations. And so by doing, it's done all the calculations, and we can have a look at the column. We'll just go to say 7 column. This tells me the value of the column in the 7th. So similarly, each of the flotation models have been created. So it uses very simple concepts to simulate what otherwise would be a fairly complex system. And to do this manually, I don't know how to take it. A week, a month, I don't know. Make an error, go back, check everything. It's error prone, not using this method. So this method automates everything, it's fast, it's simple, and it's very useful for teaching purposes. So that's really all I'm going to discuss here. I hope you've enjoyed the presentation, and I look forward to hearing from you. If you want to do one of the courses on being trained to use it. And I'm a very approachable guy, so if you are interested, just write to me, I'll write back. The name is Stephen Rayward on LinkedIn, very easy to find me. Look forward to hearing from you. All right, so that's it, and I have to fix up a few things there. It was good sort of sharing it publicly, makes you more critical. So, but that's the idea, is the fact that it's been simply looking at a flow chart, doing copies, but making sure the relationships are put into the worksheets. And that's simulation. And as I said, I don't think it's rocket science, but I haven't seen any other thing like that at all. So, questions?
Thank you very much, Stephen. We will open for questions. I have one question online, and then I'll go back to the.
Is it from Mosen?
No, it's from Francisco.
All right.
He said that you mentioned different views of what mass balance is, and then he asked, can you expand on these views?
In a minute, I will. When I was in South Africa, when they spoke about mass balancing, they simply referred to solid flow and water flow. And when I would say, well, no, mass balancing is also assays, they would say, oh, that's data reconciliation. They would use a different term for it. Now, if there's anyone from South Africa or the African region, you can correct me, but they were quite adamant that that's the terminology they would use, data reconciliation. Then we have the confusion with Medicount systems. So Medicount uses mass balance, but we do see more and more that Medicount is being used as a term rather than mass balance. And that generates confusion, because if you say, have you done a mass balance of your plant, they may say yes, and then you find they've done a Medicount of their plant, which isn't really useful for understanding mineral processing. It's good for understanding what you're delivering to the client. And yet when I was in Lynn, they were actually applying the models, and because they were applying the models, they were getting consistent data, and therefore they said they were doing a mass balance. Does that make sense? Because the results were mass balanced.
Yeah, thank you. Any questions from the floor?
Go, Craig, please.
Okay, Steve. We'll ask a question. The example you presented was straight through. Obviously, the issue with different forms of mass balancing is recirculating loads.
Yeah.
How does the system deal with that?
To clarify, even mass balance is an example where it's more complex than just a downward calculation method. So this is what I presented was a downward calculation method. So if we were to apply what I just said to where there's a recirculating load, we're going to hit the terrible circular reference. Yeah, and so it's going to get upset with you. I actually haven't, the mass balancing is different. The models get more, there's two ways. One is you stick to the downward approach, or the other way is you use a downward upward approach. So you're not only, so just because the flow is going that way, your calculations don't have to go that way. You can be using what's here to calculate what's there. And so it becomes complex, and you do this adjustment taking into account both the input flow and the output flow. Is that clear? Because if it's not, I might repeat it because it's an important concept.
Yeah, I see you getting towards the convergence.
Yeah, a convergence methodology. But just because your flow is going this way doesn't mean your calculations go that way. So I have set it up to handle more complex scenarios where you're actually using what's here and what's there to readjust what's here and what's there, rather than just downward. That's one solution, and that's what I'm doing in the mass balance. Now, if I were to stick to a downward flow, then I would simply break it at a particular point to stop the circular problem, And then I would have a second application which would then link it. So does that make sense? Otherwise I have to sort of use a whiteboard. Yeah. So I might add, that's a very good question, and it shows that you've actually understood things, so I very much appreciate it. But it is something I kept in mind, but obviously it would have been difficult here to explain that, but in the simple application. But yes, I have thought of those things.
Yeah, we have another 2 questions from Kim. She says, hi, Stephen. Very interesting to see what you have been doing. One of the problems that David has encountered is that links need to be rewritten when Excel is upgraded. Then she's asking, is your system going to be affected by this as well?
Well, I don't know why Dave Weissman has to rewrite Lib because of upgrades.
And another question is,
Well, no, I might just answer it a bit more, but Microsoft is very hard to understand what they're up to. I can't figure it out at all. I use, as I said, I like Visio, but the last time I looked at Visio with the cloud-based system, they'd completely ruined it. And they wouldn't know that they'd ruined it. Microsoft just doesn't have the understanding of its own software to know they've ruined their own software. You actually find seminars on people talking about Microsoft 365 and the upgrades to Excel, and they're always talking about you lose this functionality, this functionality, this functionality. And I'll go, why on earth would you bother with it? It doesn't make sense. And they go, oh, because it's cloud. Now, if you're using a desktop, I come from a world in which when you had a PC meant personal computer. It didn't mean public computer. And so the cloud, everyone was going to the cloud, and it's very confusing. So I'm still focusing on it very much from a personal computer viewpoint. And that will be there. Just get old versions of Excel. I mean, you go into LinkedIn, you find people who just won't do upgrades of Excel because they've been butchered. You know.
Okay, her other question is, do you foresee being able to model fit in ExcelFlow? She says, I found limitations when using Solver. Is there an ability to solve in a different way?
Oh, the answer is yes. Firstly, I did say connect to a database is important. I don't exactly know how people do it generally. All I know is how I would do it. I generally can create my own algorithms for model fitting. And so I don't really have a problem. But I have developed my own optimization system as well. So it would be interesting, if that is from Kim, for her to send me her data and her attempt at model fitting. And I could try my own system and see whether that worked. But then there are commercial solvers. So there's risk premium solver, which I actually don't like, but they're there. So, you know, that is a separate topic, optimization. It gets quite difficult.
Thank you. We have another question that's all tested for you. We're passing the time. And I invite everybody that has questions to talk over the coffee break, please. Next week, we will have Dr. William De Beer from ESG Solutions present on passive seismic data and rock mass characterization. So we hope to see you. And please let me to thank you, Dr. Stephen Rayward.
And thank you all for coming.